My name is Tao Soon. I'm a postdoc working with Professor Nathan McDonald at Brigham Women's Hospital. Today, I'd like to share some results about our ongoing project using focused ultrasound to enhance PD-1 checkpoint blockade therapy for treating glioblastoma. And as we all know, we're using a focused ultrasound together with systematically circulating microbubbles as a unique physical approach to open the BBB. And this approach can be used to open up the transcytosis, opening up TEC junctions and promote transcytosis after the treatment. And then the drugs can be slipped into the brain parenchyma for treating neurological diseases. So here we are typically interested in using this drug delivery approach to exert as a immunomodulation role into the immunotherapy. And here I'm showing a very nice illustration adopted from a review paper from Price Lab and the UVA to summarize the speculated role of focused ultrasound immunomodulation. So specifically, we think that the speculated roles of focused ultrasound can be summarized as three bullet points here. First of all, we think the delivery of antibodies can be enhanced, and this is well accepted in the community now. And in addition to that, by the cell membrane disruption, we can enhance the tumor antigen release, and further, we will improve the DC maturation. Thirdly, which is the central hypothesis and focus of this work, we think that by using focused ultrasound, we can enhance the trafficking of the immune factors. And with a greater antigen flow to the lymph node and the opening of the BBB, we think that T cell migration and recruitment can be less restricted. And in addition to that, we may reprogram the myeloid cells towards a more anti-tumor phenotype. And moving on to the results, firstly, we confirm that the combination therapy, focused ultrasound plus anti-PD-1, can improve the survival curve across all the groups tested. And this has been done using GL261 LUK2 mice models. And further, we are testing the immune profiles of the tumors and lymph node and spleens. And the panel is quite large here, as we don't really have a specific hypotheses before the study. And we're testing the major immune cells that may change the PD-1 therapy effects. So the results are quite encouraging in terms of the T cell infiltration exhaustion. We found that locally, we can enhance the T cell infiltration to the brains using the combination therapy. And we specifically found that the TIM3 markers of the T cell exhaustion has been elevated across all the organs. And we're thinking it's suggested that the combination therapy promotes the anti-PD-1 effects. And in addition to that, we also found that the macrophage are programmed towards a more anti-tumor phenotype, which is M1 phenotype defined here, in the brain, tumor, cervical lymph node, and spleen. And we found that a combination group significantly enhanced this M1 phenotype macrophages across all the groups tested. So lastly, we also characterized the dynamics of the immune cell trafficking after 1 hour of focused ultrasound treatment. So here we're using the same model together with the labeled splenocytes, and the cells were injected intravenously, and we did not use PD-1 therapy here, and we're trying to decouple these effects by showing only the focused ultrasound effects. And the results show that both in the tumor border and the tumor core, we can see enhancement of the cell infiltration and recruitment into the tumor compared to the control. All right. To summarize, we showed that the treatment efficacy can be improved using combination therapy in the GL261 model, and specifically, we improved the survival profile and also the number of long-term survivors. And we're currently characterizing 005 model, which is another mice GBM model, and trying to see if that works as well. And secondly, we found that the immune cell population and functions are changed after the treatment. Specifically, the T cell infiltration can be enhanced, and there are more M1-like macrophage accumulated into the brain and also the cervical lymph node and spleen. Lastly, we also characterize the dynamics of the immunomodulation of the focused ultrasound using the intravitreal microscopy. We found a transient recruitment effects after 1 hour of post-focused ultrasound treatment. We are currently characterizing a more longer-term effects. And with that, I would like to acknowledge our funding sources, the mentor team, and all the lab members. Thank you.